is the justification of plans track on Hartopp and Lannoy point towers. These structures are large panel system structures, meaning that they require particular attention. I'll refer you to our previous CPD seminar on LPS structures that I believe Josh previously gave, and you can find this on our YouTube channel. The floors of the structure were made of precast, pre-stressed concrete panels due to the floor small spans, the small floor spans, the uncertainty between the connection between the sides of the panels. We couldn't prove via calculation that the 3-ton excavator that our client wanted to use on the structure to demolish it could take the load. So we undertook load testing. Following the initial analysis, we found that the worst case bending moments were when the machine was operating on its toes in the orientation shown here, where this is the slab section. So we've placed that at the edge of the panel to test that interface and make sure that it is as we anticipate that the load either transfers or to test whether it does or doesn't. And similarly with the shear case, we've applied the load against the edge of the panel and towards the support of the panel. We obviously previously undertaken calculations to determine which was the critical check, and then implemented that on site. So in order to replicate the loading to the panel, we detailed a propping system that jacked off here. So if you can see my mouse, this is the point of load application. So if you see section C here, you would see this. So we've got two sections of superslim here at the base, and they represent the two toes of the machine. And we've got, if you imagine, the load starts here and works its way up, because that's the point of application. So the point that's being loaded by this jack, and that's pushing up against these beams here, which are these beams here. That load is then transferred up and then transferred into the slab, and we've taken a portion of this slab's self-weight, and we are going up again, and we're taking a portion of this slab's self-weight to provide the load to push from onto the system, or onto this slab here. These sections here were just put in to aid buildability, but became loose when the load was applied. So that's how the moment was checked on the slab, and you can see here there's a photo of the lower system during the testing or before the testing. Similarly, we've got the shear testing arrangement. Slightly different arrangement was used here due to the proximity to the edge of the slab. We found it best to put, so that you imagine the load's coming up here off the jack. We took the load and the vertical restrict, or the self-weight of coming down the wall to resist against when we jacked from. We also included an additional prop to take out the horizontal force that we're applying to the wall. You can see here the jacking arrangement. A section through the test setup can be shown here. We detailed it so that the engineer can load the structure off to the side, as mentioned previously, from the adjacent bay. The load test is taken in increments, and yeah, essentially the engineer on site would monitor the slab as the load is applied very vigilantly, and that is how we undertake